Hey everyone, my name is Sinead, and in this video I'm going to be going over the basics of significant figures. There's a lot of controversy regarding significant figures, and I'm not the expert on it, but this is just my tactic and how I approach significant figures whilst I was doing my exam. So this video is going to be broken up into two parts. First, I'm going to be talking a little bit about the theory, and then I'm just going to go through a bunch of examples because I think that's the best way to wrap your head around significant figures. I will also link some resources in the description behind the theory of significant figures, and I will also include timestamps in the description so you can skip around to whichever part is most relevant to you. Okay, so first I'm going to talk about how you can figure out how many significant figures a number has. So this is basically how I think about it. So basically, to figure out the number of significant figures there are in a number, think about what it would look like in scientific notation form, and then the number of figures in that scientific notation form there are, that's the amount of significant figures that there is. Let's break this down. Okay, so for example, 0.78, there's a 0, there's a 7, there's an 8 in it, but that's not three significant figures, because if you were to write it in scientific notation form, then that would be 7.8 times 10 to the minus 1. So actually there's only two significant figures. The standard value of number of significant figures that you should have is 3. So when you're doing your IA, you should always include at least 3 significant figures. Obviously there are exceptions. Sometimes you need a lot of decimal places, but for the most part you need at least 3 in your IA. Another quick note is that significant figures is not the same as decimal places. So if it says write the answer correct to 2 decimal places, that doesn't mean correct to 2 significant figures. Decimal places is how many digits there are after the decimal point, while significant figures talks about significant figures. It's different. However, when you're doing practice papers, it's not so simple as just 3 significant figures. There's actually a bit more that goes into this. So whilst you're doing your practice papers, the number of significant figures in your final result should be equal to the smallest number of significant figures that is present in the question. So what does this mean? We're going to dive into it a bit more. And the best way to explain this is just through a bunch of examples, so we're just going to be going through some examples. So if the question uses the values of 32 kilograms, 64 meters, and 24 meters per second, then you should quote your calculated value to 2 significant figures, as each of these values have 2 significant figures. And then you do a calculation and you find that your answer to whatever question you are asked is 2,311, and you should quote your answer to 2 significant figures, as all of the values used in the question have 2 significant figures. So that means quoting your final value as 2,300. If the question uses the values of 3,239, 6,439, and 9,297, all of these numbers have 4 significant figures, and that means your final value has to have 4 significant figures. And so if your calculated value again is 2,311, rather than rounding to 2 significant figures or 3 significant figures, you keep it at 4 significant figures. So it stays at 2,311. However, if in the question the numbers are given as 32 kilograms, 6,439 meters, as well as 9,297 meters, and it's not 32.00, then you have to quote your final value to 2 significant figures, because as you can see here, 32 has 2 significant figures, and that's the least amount of significant figures there are present in the question. Therefore, if your answer again is 2,311, you don't quote it to 2,311 because that's 4 significant figures. You want to quote it to 2 significant figures. So the answer is 2,300. And so what I'm going to do is I'm going to go through a bunch of IB problems and look at all of the numbers and then show you how I figure out how many significant figures I'm going to quote the answer to. Okay, so let's look at some examples of real IB physics problems. These are all taken from IB physics questions. So I'm not going to read the question, I'm just going to be looking at the numbers, and then I'm going to be telling you how many sig figs you would quote it to. And hopefully after this you'll get a hang of it. That's 2 sig figs, that's 2 sig figs. That is not, that's not really, that's one of those weird things where 0 kind of is an exception to most number rules. That's 2 sig figs, that's 2 sig figs, that's 2 sig figs. So all of these numbers are in 2 sig figs. As you can see here, this is not 4 sig figs. This is actually 2 because the 4 is 1, the 4 is 1. Not the zeros. Those are not significant figures. So you're going to quote, so it asks for the specific latent heat of fusion of ice, and you're going to have to give that in 2 significant figures. So how many significant figures is this? Well, that's actually not 3 significant figures. That's 2 significant figures. In scientific notation, it would be 9.0 times 10 to the minus 1. That's 2 significant figures. Here, 670. So 670, that would be written as 6.7 times 10 to the 2. So that's 2 significant figures. So both of these numbers look like they're in 3 significant figures, but they're actually 2 significant figures. So in this question, you want to quote the number to 2 significant figures, not 3. 2 significant figures, 2 significant figures. See, it's already in scientific notation. And so you want to find the pressure, because both of the numbers are in 2 significant figures. Then you're going to quote the value to 2 significant figures. Okay, what about this one? 6.2 times 10 to the minus 4, that's 2 significant figures. 1.4 times 10 to the minus 11, 2 significant figures, 1 and the 4. It wants you to deduce the activity, and because both of these numbers are to 2 significant figures, you're going to do it to 2 significant figures. Okay, next, slits are separated by 1.5. 2 significant figures, easy. 5.0, that's not 1 significant figure. The 0 counts in this case, so that's 2 significant figures. 6.3, that's 2 significant figures. And so the answer for this one should be in 2 significant figures. 0.61 and 28. In this case, 0.61, that's 2 significant figures because it would be 6.1 times 10 to the minus 1, and 28 kelvin's 2 significant figures, so the answer here should be in 2 significant figures. The 8.0, that's 2 significant figures. 0.24, that's 2 significant figures. So basically, like, the 0 in front of values don't count, but then the zeros behind values do count as significant figures. Both of these are in 2 significant figures, so the answer should be in 2 significant figures. That looks like 3, but it's actually 2. 2 sig figs. 2 sig figs. 2 sig figs. 2 sig figs. That's the end of this video. Thanks for watching. I hope you gained a bit of knowledge from this. There's always going to be exceptions in the IB. The IB isn't so like straightforward about this. So you might see that like they use 2 significant figures for every single value, but then the answer in the mark scheme is 3 significant figures. It's a bit weird and it's not super straightforward as to what the IB wants us to do. It's not that big of a deal. As long as you just get like a good intuition for it, you should be fine. So yeah, that's all for this video. Thanks for watching, and I'll see you in my next video.